Hello everyone, so today's video is dedicated to factoring polynomials before multiplying. So we're going to go ahead and get started, and this first line just reads, cancellation can also be used when multiplying fractions containing polynomials. However, it is very helpful to factor binomials and trinomials before canceling. This is kind of just a combination of the last 2-3 lessons we have gone over, and it's just kind of bringing it all together. So we've learned how to factor, we learned how to reduce fractions using cancellation, and now we're just going to combine the two, okay? So in this case, our example is going to be, we'll just put it this way. Our example is going to be this right here. So we are going to be multiplying this fraction and this fraction. So our first fraction is x squared minus x minus 6 divided by 2x, and this is going to be multiplied by 4x squared divided by x squared minus 9, okay? So the first step in all of this is to factor. Now, the way we factor is kind of like normal. It's what we've already been doing. So if you see here from our original expression, we have x squared minus x minus 6, which gets factored into first x plus 2 in parentheses and x minus 3 in parentheses, okay? And now the 2x, there's nothing to factor that into, like you can't break that down anymore, so that remains the same. The 4x squared is the same deal. There's nothing to break it down into, so that stays the same. But this x squared minus 9, which I want you guys to notice, is a difference of squares. We have x squared and we have 9, which is a square. It's a perfect square. So this down here is a difference of squares, which means it's easily factored into x plus 3 and x minus 3, okay? So we've officially factored all of these. If you had other expressions here, other polynomials, this is what we call a polynomial. It just means that there's an expression and there's more than one term. That's a polynomial. So now that we've factored all of these, we are now down to this. Now you'll see here that there are several things crossed out. This is where cancellation method is used. As many of you remember, I say look for the pairs. But you have to ensure that the pairs that you're looking for is that one is in the numerator and the other half of the pair is in the denominator. So in this case, if we focus on the x minus 3, so remember that this is still the same setup. The only thing is this is written differently. So now if we look at the factors of this, we have x minus 3 here. And then if we look at the factors of this, we have x minus 3 here. Now, both of these, they cancel each other out, okay? So they are crossed out. They're no longer existing in our equation, essentially. And then this 2x and this 4x squared, what happened here is that this 4x squared was divisible by 2x, and so was this 2x, which would break this down into something smaller, okay? And so with this, and then this would disappear and be canceled out, because our goal is essentially to get from this to something way smaller and way simpler to take care of, okay? So now, if you'll notice, we have this 2x up here because 4x squared divided by 2x gives us 2x. So this 4x squared did not fully disappear, but this is what we have left over of it, okay? With this now, what we have left over is what we get to multiply. So now we've canceled everything that we can cancel. Now we multiply across. So we have x plus 2 in parentheses times 2x, which is what you see up here in the numerator. And then in the denominator, all we have left over is x plus 3, which is right here. Now, although this is our final answer, yes, but this can still be simplified further, because now I don't want to have parentheses. My goal is to never have parentheses in my final answer. So what I'll end up doing is multiplying the 2x by the x first, which gives us the 2x squared, and then the 2x by the 2, which gives us the 4x. The x plus 3 cannot be combined because these are still two different terms. So I just bring that on over, and then this is my final answer here. Okay? So